All right, here we go with 1.4. We're going to start dealing with surface areas of things that we call right pyramids and right cones. Okay, now before we get into this, we have to look at a bit of a background thing here. So we're looking at basically what is surface area, right? Surface area is basically the outside area, okay, of any object, of any 3D object. So it's basically what you can touch. Okay, so say, look at this mug. The surface area of this mug would be the outside of it, right? If you talk about the surface area of this eraser, it's just the area of all the faces. So the surface area is the area that you can touch around the outside, okay? And we're looking at the surface area of pyramids and cones. Now, a right pyramid, okay? A right pyramid deals with what we call a right angle. Okay, so it has, no, I'm not going to say it has a right angle, but you can, let's look at what a right angle is, right? A right angle, first of all, is what we call 90 degrees. Okay, it's 90 degrees, and it's often represented by this little box in the corner, right? You've seen right triangles like this, boom, there's your right angle right there, 90 degrees, okay? Now a right pyramid is something, it's where, let's have a look at this. So here is your basic pyramid, okay? If you look at a net, when you unfold it, when we fold it back up, boom, there's your pyramid, okay? And the reason it's a right pyramid is because the height is straight up and down. It's 90 degrees, okay? The height goes straight up and down, right to what we call the top, which is actually what we call the apex, okay? So if I was going to draw a 3D picture here for you, it would look something like this. There is my square base. I'm going to go straight up, okay? 90 degrees straight up. And then I've got my four sides. And what you end up creating is a right angle triangle in here, okay? So this is a right angle. It's not skewed. I'll show you a skewed one that would be a little bit off. It means that the height would maybe go this way or something. And you can see when we draw it up, it's going to be a little bit off, right? It's not a right pyramid. So this is what we talk about when we say a right pyramid, okay? Now a regular polygon. A polygon is any shape, okay? This is a polygon. It's what we call a closed figure. This is not a closed figure. If you close it, now you have a polygon. A regular polygon is when all four sides are the same. So you can have a square, all four sides are the same. You can have what we call an equilateral triangle, all four sides are the same. You can have a pentagon. There you go, where all five sides are the same. A regular pentagon, a regular quadrilateral, which is a square, and here we have a regular triangle, which we call an equilateral triangle, okay? So that's what a regular polygon is a closed figure, okay, with equal sides. Equal sides. Now, the area of a triangle. Here, let me point one thing out here too. So what we have here is, if you look at this triangle here, our pyramid, this is what we call the base, okay? This right here is what we call the height, okay? And all four sides here, they meet at what we call the apex. Okay, let's look at a different one here, a little bit taller. Let's get rid of this so that we don't have to look at it. Here is my net, right? I hope you can see that. Here is my square base, right? And these are my four sides. They come up, boom, all four sides are the same. They come up and they meet right at the top here, which is called the apex. Okay, right at the top here, it's the apex. So the height of a pyramid is measured from the center right to the apex. Okay, we'll be looking at that a little bit more too. Now, in order to find the surface area, first of all, you need to find the area of the base, right? In this case, it's a square, so it's just length times width. And then you have to find the area of the triangles on the side, okay? And we have to remember what the area of a triangle is. Hopefully you can remember. Well, look, if you look at a rectangle, it's base times height, right? Well, if you cut it in two, you got two triangles. So base times height divided by 2 is the area of a triangle. Another way to look at it is 1/2 times your base times height. Those are exactly the same. All right, so we're going to be looking at a few different types of pyramids. This is a square-based pyramid, okay? Boom, there you go. This is what we call this is a triangular base here, okay? And when we have these, all four sides are the same, this is actually called a tetrahedron, a regular tetrahedron, because it's got four sides, okay? So this one, you can look at it here. Let's look at a regular tetrahedron, okay? Four equal triangles is what a tetrahedron is. Okay, we can also have a different kind. Look at this one here. This has got 6 sides, and if you fold these up, you're going to end up with a pyramid, but it's got a hexagon on the bottom, and still they all meet up at the apex here. It starts looking like a Chinese dumpling or something. But I hope you're getting the idea with these pyramids. You can have any shaped base, okay, and still make a pyramid out of it. So what we're looking at is how to find the surface area of these regular pyramids, or of these right pyramids and right cones, okay? And what we need to look at is a couple different things here. Let's look at the, so to find surface area, okay, to find surface area, you need to find the area of all the faces. So that includes the base plus the sides, which are all triangles. Okay, so your base could be a square. Boom. There is your square-based pyramid, right? Let's see if I can draw a triangular one. There you go. That's got a triangular base. It's a little bit harder for me to draw the other ones, but your base can be anything, okay? And I showed you a couple. Here's a square base, boom, fold it up. Here's a hexagonal base, boom, fold them up, okay? So you need to find the area of the base and then the area of all the 4 triangles. Now, the base is the easiest part. The biggest problem you're going to come across is when you're trying to find the area of the triangular sides. Okay, because you might be given, let's draw a better one here. Let me draw another one here. If I have, say, a square-based pyramid like this, okay, boom, 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 boom. You have the height here. You might have this length here too. We're looking at the slant height there. So this slant height here, this is what they call the slant height. Okay, that's the angled height, because this height right here, that's the real height of the pyramid. That's how high the pyramid is, but that's not how high these triangles are, right? If you look at this, it's on an angle. You look at these, they're on an angle. So this height right here will not be the height of the triangles. The height of the triangles is this line right here. So how the hell do we find that? Well, this is where we need to look at something called Pythagoras. If you can look at this triangle right in here, it's a right angle right there. If you look at that triangle, you'll hopefully see that you have a right angle triangle. If you're given a height, say, of 12, and say this was 5 here, if you did what we call Pythagoras, you could find this slant height. So 12 squared plus 5 squared is equal to x squared. 144 plus 25 is equal to x squared. 169 is x squared. 13 is equal to x, because you square root both sides. So what's happened here is that you found a slant height of 13, which is a little bit longer than the actual height, right? So now to find the area of each of these triangles, if this is 5 here, you can see that's 5. That's half of the whole thing, right? So the base, the whole base was 10. This half here is 5. So that's how we got the 5 there. 5. This height here is 12. You only need that height to find the slant height. So now the base in this case is going to be 10 times 10, because it's a square base, which is equal to 100. And then the sides now, you have base, which is 10, times the slant height, which is 13, divided by 2. That's going to be 130, or divided by 2, which is 65. And you have 4 of these, right? Because you got 4 sides. So 4 times 65 is equal to 260. plus the 100, you have a total surface area of 360 units. Okay, I know I kind of flew through that pretty quick, but it shouldn't be too hard. We'll do a few examples in class and hopefully we'll get the hang of it. What I'd like to show you quickly now is if you had a tetrahedron like this, for example, and you're given all the sides, say, well, you'll probably have to be given everything here, right? You'll be given this height. If this is 10 here, and this is 10 here, and this is 10 here, you'll be given the height here as well. That'll be, if this is 10, right? If that's 10, that's 10. We could probably find this out. That means that this is 10 here, right? That means that this half here is 5. So now you're going to have to find this thing here, and that's going to be 10 squared plus, no, sorry, 5 squared plus x squared is 10 squared. So x squared is equal to 100 minus 25. X squared is equal to 75. That means the square root of 75 is going to be about 8, 9, say 8.6 about. All right. So now you have a height of 8.6. So now your area of the area of the triangle is equal to base times height divided by 2, which is 10 times 8.6 divided by 2, which is 86 divided by 2, which is 43. And I have 4 of these sides, 1, 2, 3, 4. So that would be 160, 172 units of whatever they are. So we have tetrahedrons, we have regular pyramids, we have to use Pythagoras to find these slant heights that we're talking about. Where's my picture here? These slant heights that we're talking about, okay? And that's essentially what we're talking about when we're looking for the surface area of pyramids. The one other thing that we need to look at here are cones, all right? And a cone is a special type of thing. A cone has a special formula. Let me quickly draw a cone. It has a circular base, and then it has a peak up here. It's like an ice cream cone, an upside down ice cream cone. I'm pretty confident you know what a cone is, okay? But we have the same thing, the center. The center to the edge is what we call the radius, okay? And then we also have the height right here. This is what we call the height. Okay, and then you also have this side right here, and we call this S for slant height. Okay, and you'll probably have to do some Pythagoras again. If you're given, say, the radius and the height, you'll be able to find the slant height. And the formula here for surface area of a cone, okay, is equal to pi r squared, because that's the area of the bottom, right? That's the area of a circle. So remember, area of circle is equal to pi r squared. That's what we have here. And now the side is a little bit different, okay? When you unwrap a cone, unfold the cone, you end up with this funky little net, okay? Where this is the base, and you fold this around to make your cone. This isn't such a pretty thing, but we have a formula for this, and it's pi rs. This is the surface area of a cone, the formula you will be given. I'm not a huge fan of formulas for the pyramids and stuff because I believe that those are just logical. The area of the base plus the 4 sides, okay? So look at your pictures, see what type of shape you have, learn how to find the areas of squares and triangles and rectangles and circles, and then this shouldn't be a problem.